All right, chapter 2, section 3. We're going to talk about analyzing graphs of functions. What does it mean to analyze? Like to interpret. We're going to look at. We're going to figure out a whole bunch of stuff out from graphs. Okay. All right, this is going to be very, very important that you guys write this down and pay attention. Domain are all the values on the x-axis, right? X-axis, we read from left to what? To right, just how you read a book, okay? Left to right is our domain. When we talk about range, range is our y value, correct? We're going to read that from bottom to top, all right? Another way that you guys could think about that is low to high. It's going to be really, really, really important that you guys pay attention to that. We're always going to put our answers in interval notation. If you have a closed or solid dot, we're going to use brackets. And open dot uses parentheses, right? Parentheses. I think that's how you spell it. Something like that. All right. So I'm going to say this a bunch, and I want you guys to really, 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 really pay attention. But when we talk about intervals of increase, decrease, and constant, you only use parentheses. I'm going to write that again here in a minute. When we talk about increase, decrease, and constant, write this down. X-axis only. All right? You guys are going to see where a graph is increasing, it's going up. Decreasing, it's going down. Where it's constant is horizontal. I don't want to know how much it goes up or down, how high. I want to know over the interval of which it happens. From here on the x-axis to here on the x-axis. We'll talk about that in a second. But increasing is where your graph is going up. Decreasing is where it's going down. And constant is where we'll say it's flat. It's horizontal, left to right. Always interval notation. And you're always going to use parentheses. Why? The reason you only use parentheses on increase, decrease, and constant is because you cannot simultaneously increase and decrease, or increase and stop, decrease and stop at the exact same time. Right? There's never a point in time, like if you are at a stoplight and then you all of a sudden go in your car, there's not a point in time where you are stopping and going at the exact same time, so it's never going to be included. So we're only going to use parentheses, okay? All right, so let's talk about this kind of stuff. You guys are going to get graphs. You're going to talk about domain, range, increase, decrease, and constant. First of all, what does it mean when there's an arrow at the end of a graph? It just keeps going, right? It just keeps going. It never ends. When there's a specific stopping and starting point, then you have a dot. But do you see how there's an arrow here at the top here? It's never ending. So when we talk about domain, all right, we read domain from left to where? From left to right. So I'm going to start over here on the left-hand side. This is my negative infinity on the x-axis. This is my positive infinity. And I'm going to tell myself where this graph starts and stops on the x-axis. Furthest left, where does the graph start? That's at -3. Does it include -3 or not? No, it's an open dot. So then it keeps going. And where on the x-axis does it have a stopping point? At 0. Good. Does it include 0 or no? Yes. Okay, good. Then what happens? There's kind of a break in the action, right? There's no values on the x between that solid dot and the open dot being used. We're going to use a union. Where does the graph pick up again? And what number on the x-axis? 2. Does it include it or no? And then it goes where? To infinity. Now, I understand that graph is going upwards, and you guys are thinking it's going towards positive infinity. But what we're reading is from left to right. So, yes, this is going upwards, but it's going to continually get wider. So it's going to continually use these x values. That's the infinity we're talking about. What do I put on the end of my infinity? Parentheses, always, okay? So now let's talk about range. How do we read range? From bottom to top, okay? So where on the y-axis, from the bottom, does my graph start using values? At 0, right? Nothing down here is on either piece of that graph, correct? So it's starting at 0. Does it include 0 or no?
Yes.
What kind of a dot is right here? It's open, right? The furthest, but that's going to be an open dot. Right here. That dot is open or closed? Open. We're reading right here. What is the value of y right there? It's 0. And then it goes up to what on the y-axis? To 2. Does it include 2 or no? Yep, so we put a bracket. Then there's a bit of a break, correct? Okay, so that we have a union. Then where does it start again on the y? At 3. Does it include it or no? No. And then it continues to go where? To positive infinity. If you guys need to use color pencils and stuff when you come in here for your test, that's perfectly fine. All right, so we just read our domain and range. It's a lot easier when you have specific starting and stopping points to read domain and range. When you have arrows, it gets a little bit more difficult, but we just got to practice this. Now we're going to talk about intervals of increase, decrease, and constant. Where do we read increase, decrease, and constant? What axis? The x-axis. Pay attention to that. We read on what axis for increase, decrease, and constant? The x. I want you guys to do this. Cross off the y. Don't even look at it. Don't look at those numbers. I am not worried about how high the graph goes, how low it goes. I'm looking at the interval over which it is increasing. So we're going to talk about increase, decrease, and constant. All right, we read left to right. Increase means your graph is going up. Decrease means your graph is going down. Constant means it's staying the same. So starting right here on the x-axis and the x-axis, what is your graph doing? If you put your pencil right here and you move like this, what's it doing? It's going up. It's increasing. So on the x-axis, from where to where is your graph increasing? From -3 to what? To 0. Good. Parentheses only. So then I look over here. What is my graph doing from here to here? On the x-axis, what is my graph doing? It's increasing again. So from where on the x-axis to where? To infinity. Okay, so now I have to look and say, well, what's my answer for decrease and what's my answer for constant? NA, none, something like that. Tell me that there isn't. Don't just leave it blank. That is totally okay to have no intervals of something. You could have no increase, no decrease, no constant. That's fine. But you have to account for it. You can't just leave it blank because then I think you guys don't know. Does that make sense? All right. Let's do the same thing again. Increase, decrease, constant. Domain and range. The more we do this, the better we're going to get at it. First thing I'm going to do is my domain. Domain is what? X-axis. So negative infinity over here, positive infinity over here. Where does this graph begin? Well, think about it, guys. Yes, I understand this is going downwards. But I'm not talking about how high or low it goes. I'm talking about how wide it goes. So as it goes down, it's going to continually get what? Wider and wider and wider and wider. So where does this graph start on the left-hand side of the graph? Negative infinity. Good. And it goes to what number? Does it include -2? No? Good. But then there's a break in the action. And where does it start again on the x-axis? 1. Does it include 1? Yep. And then goes to 2. Perfect. Does it include 2? Perfect. Now we're going to talk about range. We read range from where to where? Bottom to top, low to high, however you want to say it. So where does my graph start using y values? Negative infinity. Good. What am I doing? Negative infinity to what on the y-axis? To 0. Does it include 0? No. Okay, good. So there's a break, and then what happens? Where does it start again? 1. Good. Does it include 1? Yes. And then goes to where? Does it include 2? No. Okay, good. Very good, guys. All right, increase, decrease, constant. Where do we read that? X-axis. So what should I do to the y? Just cross it off. Don't get yourself confused. I don't care how high or low it goes. I want to know over the intervals in which it happens. Increase, decrease, constant. Look at it for a second, guys. If you put your finger or your pencil on each graph and you're reading from left to right, what is each piece doing? It's increasing again. So what can you already write for decrease and constant? None, okay, that's fine. So where is this graph increasing? From where on the left side to the right side? We start on the left side. Where is it increasing from? Negative infinity to negative 2. Good. Parentheses only. Then what does your graph do? Union. Then what? From where to where? 1 to 2. Do you guys notice how sometimes the domain and the intervals of increase, decrease, and constant mimic each other? Right? They're not always exactly the same. Sometimes they are. But that should correlate because you're reading both of those things on the x-axis. All right, let's do the next one. What do you guys notice about this one? Increase, decrease, constant-wise. Is there an interval of increase? Yes. Is there an interval of decrease? Yes. Is there an interval of constant? Okay, good. You should be able to recognize that. So if I'm reading domain from left to right, negative infinity to positive infinity, what are the values that I'm using on my graph? Negative infinity to negative 3. Does it include negative 3? No, okay. Then what? Union, good. Bracket, negative 2 to positive 1. Parenthesis, awesome guys. Then what? U, 3 to infinity. Perfect. Very good. So my range, how do I read range? Y-axis, low to high. Where does the graph, where does it begin having values? At positive 1. Does it include 1? Is there any place on that graph where 1 is included? Yes. Are there places where 1 is not included? Yes. But if there is at least one spot that is included, then you're good to go. So it includes 1. Because right here on the y-axis.
Oh, it has to be the first thing touching?
Mm-hmm. So it doesn't have to touch, just where it like, because there's nothing down here on any part of the graph, right? It's where any y value exists. So what is my range? From 1 to what? Ooh, why is it positive infinity? Isn't there a break though? Like there's no y values being used right here. But are there y values being used over here? Yes. You only have a break if there's absolutely the absence of those values in the entire graph. If there's one little piece that's using it, then you're good to go. You have to include it. So let's talk about our increase, decrease, and constant. We already talked about the fact that there was a piece, all of these things existed, correct? Let's cross off our x-axis. I don't even want to look at it. Yeah, did I say x? I'm sorry, thank you. Cross off the y, I don't want to look at it. Read your graph from left to right. What is that first piece doing? Is it increasing or decreasing? It's decreasing. So your interval of decrease is from where to where? Negative infinity, good. To negative 3. Does not include. We're going to have parentheses. Then what happens from negative 2 to positive 1? It's constant from negative 2 to positive 1. And then what happens? There's only parentheses on increase, decrease, constant. Always. And then what happens? From where to where? Positive 3 to infinity. Perfect. Good job. Okay, guys, I just duplicated this slide. I'm going to do the increase, decrease, constant, and all that stuff at the end, just because we just did 3 examples. I'm not going to spend more time on this. I'll do it at the end of the video and upload it. But I do want you guys to see the F of questions. Remember, what kind of a notation is this written in? Well, this is called what? Function notation, right? This is F of X. What this question is asking, once I explain this, you'll be like, oh, this is so easy. They're telling you where to look on the x-axis. And F of X is a fancy way of saying what letter? Y. So they're saying, okay, at 0, look at the x-axis and tell me what the y value is. So at 0, if I go to the x-axis at 0 and I look and see what is the value right there of y? Negative 4. F of 0 is negative 4. They're saying, hey, on this graph, look at 0, tell me what the y value is. So f of 3, that means you go over here to 3. What is the y value? It's 0. Good. And here, f of 0. So go right here to 0 on the x-axis. What's your y value? 1. Good. F of negative 3. Okay, so go over here to negative 3. What's the y value? What is it? 1. Whoops, put it in the wrong spot. 1. Go to 1. Oh, jeez. Sorry, I went over here. That's what I meant to do. Negative 3 is 1. Good. And then f of 1, it's 1. Good. I'll do the domain and all that stuff at the end. I don't want to waste time doing it. But does that make sense? When they say f of a number and they give you a graph, they say, hey, look at where that is on the graph and tell me what the answer is. Okay, even and odd functions. You guys are going to talk about even and odd and symmetric to this and that. This is the book way of doing even and odd. I'm going to show you a shortcut that I like that I think is a little easier for you guys to see. But if a function is even, it has symmetry to the y-axis. What does that mean? Y cuts in half, right? If a graph is even, it means if you folded it over the y-axis, it would be symmetric. It would fold on top of each other. An odd function is symmetric to the origin. It's always going to go through the origin. Think odd, origin. Okay, so what this is telling us to do is to plug in negative x. And if you get the same thing, once you plug it in, you get an even function. If you get the opposite, you get an odd function. Let me explain to you what this means. I'm going to tell you guys to determine even, odd, neither, a little bit of a different way. So let's look at this question. First thing you're going to do, if it says, find out if the function is even, odd, or neither, you're going to look at the highest exponent. It may not be first. God bless you, but look at the highest. Okay? If we look at the highest exponent, what kind of a number is 3? Even or odd? It's odd. Okay? So your function is either odd or neither. If the highest exponent is an odd number, it cannot be an even function. If the highest exponent is an even number, it cannot be an odd function. So your two possibilities are odd or neither. If a function is odd, I want you to think of this. The direction of the arrows is opposite. They're always going to be one up, one down. On a graph, always going to be opposite. So algebraically, I want you to do this. Set this up. I'll show you. I'll explain this as we go. I didn't mean to write that. Now, I told you to plug in x or negative x, right? If I plug in negative x here, you guys don't have to write this down. If I plug in negative x cubed minus negative x. Well, what is negative x cubed? Negative x cubed, right? And then minus the negative is plus x. Are these two, here and here, are they exact opposites of each other? No. So this is an odd function. That's hard to tell. You guys are going to get confused by doing this. This is what I want you to do. I want you to pick any number in the entire world. Any number in the entire world bigger than 1. Okay, you said 7. Okay, you guys said 2. All right, everybody do this with whatever number you just picked. You're going to take that number you just picked, I'm going to say 2, and its opposite. And you are going to plug it in and evaluate. So over here on this side, I'm going to say 2 cubed minus 2. What's 2 cubed? 8, and 8 minus 2 is 6, okay? Now I'm going to do the exact same thing over here, and I'm going to plug in negative 2. What's negative 2 cubed? Negative 8. Minus the negative is plus 2, right? What's negative 8 plus 2? Negative 6. Are those two numbers exact opposites of each other? So your function is therefore odd. That trick will work every time. It is so much easier to use numbers than it is to use x and negative x.
How do you know
in 1 second. Give me 1 sec. Now, they have to be exact opposites of each other. Did anyone else use a different number?
I used 5.
You used 5. What'd you get?
I got positive 120 and negative 120.
Okay. So it doesn't matter what number you use, just as long as you use a number and its exact opposite. If you think the function is odd, the answers that you evaluate and get will be exact opposites of each other. Let's look at this one. Highest exponent is a what? A 2. So what kind of a number is 2? Even. So this function is either even or what? Neither. Well, graphically, if you have an even function, the arrows are going in the same direction, either both up or both down. So algebraically, if we evaluate, what should the answers be if this is an even function? The answer should be the same, all right? Everybody use a different number. Got to be bigger. It's got to be 2 or bigger. Can't use 1. I'm going to use 4. If you want to use 4 or 2 and negative 2 every time, you can. I'm just trying to show you that you can use anything. So if I plug in 4 squared plus 1. 4 squared is 16 plus 1 is 17, right? Over here, I'm going to plug in negative 4. Negative 4 squared is 16 plus 1 is 17. Are those two answers the same? Yes. So then I just proved that this function is even. Now, if you use 2 and negative 2, what did you get as your answers? 5. If you use 3 and negative 3, what did you get as your answers? 10. It doesn't matter the numeric value that you get. You have to look at the answers and compare them. If you think it's an odd function, then they should be opposite of each other. If you think it's an even function, then it should be the same. Now, let's talk about if it has symmetry. That last slide, it said if the function is odd, it's symmetric to the what? No, odd. Origin, symmetric to the origin. If it's even, it's symmetric to what? To the y. Y will cut it in half. That make sense? All right, let's look at the next one. Highest exponent. It may not be first. I told you that. What's the highest exponent here? A 1. There's a 1 there. What kind of a number is 1? It's odd. So this function is either odd or what? Neither. Tell yourself from the beginning so you don't get confused. So that means when I evaluate this, my two answers should be what of each other? Opposites. Good. So I'm going to use 2 and negative 2 again. Again, any number bigger than 1 and its exact opposite, you can use whatever you want. So 5 minus 3 times 2. 5 minus 6, I get negative 1. Here I have 5 minus 3 times negative 2. So I have 5 plus 6, I get 11. Are those exact opposites of each other? So this graph is, this function is neither. Does it have symmetry to anything? No, no symmetry. Does that make sense, guys? You are welcome to use negative x if you want, and then compare to the original, see if they're exactly opposite or exactly the same. I just find that to be a little more difficult. It's easier to look at two numbers and say, oh yeah, those are the same. All right, let's move along. Do we have more of these? Okay, same thing. Highest exponent. 4, all right? So think about 4. What kind of a number is 4? So this is either even or neither. Good. Again, you can be cute. You can figure out, you can use any numbers you want. Some people are like, I'm going to use 23. Okay, fine. Just makes your math harder. If I think this is an even function, what should my answers be? The same. Okay, so let's see. So 2 to the 4th minus 2 squared minus 1. Use parentheses, guys. What's 2 to the 4th power? 16 minus 2 squared is 4 minus 1. 16 minus 4 is minus 1 is good. All right, so now I have negative 2 to the 4th power minus negative 2 squared minus 1. What's negative 2 to the 4th power? 16 minus negative 2 squared. 4 minus 1. What's 16 minus 4? 12 minus 1 is 11. Are these answers the same? Yes. So this is an even function, and it's symmetric to what? To the y-axis. Awesome. Now, can you just assume that because everything is even, it's just going to be an even function? No. Please don't do that. Just always show your work. It takes 2 seconds to do this. Show me your work. If you had an even on either question on a test and say it's worth 7 points and you just write odd and you just happen to be right, you might get a point. You have to have the work to back it up. Highest exponent, 3. So this function is either odd or neither. Good. If it's odd, the answer should be what of each other? Opposites. Good. I like to set it up like this so I can actually see the answer at the end. Oh yeah, they're opposites. We're good. So again, 2 and -2 work every time if you want to. Pick whatever you would like. It's got to be bigger than 1 and it's opposite. So 2 cubed is 8 times 2 is 16 plus 6. What's 16 plus 6? 22. Good. So 2 times -2 cubed plus 3 times -2. -2 cubed is -8, right? Times 2 is -16. Minus 6 is what? -22. Are those exact opposites of each other? Good. So this is an odd function, and it's symmetric to what? Good. Even, odd, neither? Make sense now? Have you guys seen that before? No? Okay. Yep. Mm-hmm. Odd is always symmetric to the origin. Even is always symmetric to y. And if it's neither, it has no symmetry. It doesn't come into play. All right, zeros of a function. I've already taught this to you guys a few days ago when I just mentioned this. What are some other words for zeros? Good. Roots. What else? X-intercepts. Look at you guys. One more. Solutions. Oh my, you guys listen. It's a proud mom math moment. I know, I'm gonna do it. Zeros, roots, x-intercepts, solutions. They all mean the same thing. Set your function equal to 0 and solve. How easy is that? What are we gonna have to do a lot of times? There's an F word in math that never goes away. Factoring. Happens a lot. Lots and lots and lots, guys. All right, we're going to set f of x equal to 0 and solve. So this happens to be a quadratic. What should we try to do first before we just go, I'll just do the quadratic formula. Let's try it. Yeah, look for GCF and then see if we can factor it. If I multiply a times c, I have positive 2. What are the factors of positive 2 that multiply to give you positive 2 and add to give you negative 3? Look at you. X minus 2 and x minus 1. All right. My a term is not 1, so I have to divide both of these by 2, correct? So I end up with x minus 1 and 2x minus 1 equals 0. Now we set them both equal to 0. So I get x equals, what's wrong? Right here. Went out in front.
Oh, wait, I'm stupid.
No, you're not. No, don't say that. So x equals 0 and x equals what? 1/2? Now, if they ask you for the zeros of the function, they want to know what x equals. If they ask you for the x-intercepts, how would you write this? 0, 0, good, and 1/2, 0. Just answer the question how it's asked. This is zeros, and this is x-intercepts. Yeah, I have no idea why I wrote that. I was thinking to plug in 0, and I just was, yeah, my bad. X-intercepts are ordered pairs. Zeros are just what does x equal. Does that make sense? All right, again, if we're going to find the zeros, I'm going to show you a little trick here. Again, you guys will, I don't know if we learned this year or not, but when you're asked to find zeros and you have a rational function, rational is a grown-up way of saying a what? Fraction. When you have a rational function, to find the zeros, you just have to set the numerator equal to 0. I'll show you why here, algebraically. If I plug in 0 here, I get 0 equals 2x plus 5 over x plus 5, correct? How do I solve this? Well, I have to multiply both sides by what? Okay, x plus 5. If I multiply this side, then I multiply this side. So those cancel, right? What's x plus 5 times 0? 0. So you're, in a sense, you're just setting the numerator equal to what? No, you set the numerator equal to 0. That's okay. If you're going to find the domain, what would you tell me? What's the only thing x cannot be? -5. How come?
Because the denominator
It would make the denominator 0. Good. Okay. That's not what it's asking. I was just making sure we got that. So we divide both sides, yeah? And x equals -5/2. That's your 0. How many times does this graph cross the x-axis? One time. How did you know that from the beginning that you were only going to have one answer? The highest exponent is 1. How did you know at the beginning here you were going to have 2? Highest exponent. Oh, yay. Good guys. All right, we already answered this part, right? On the previous slide. Let's go ahead and do our domain and range and all that. How do we read domain? Left to right, x-axis. So where does my domain start for number 4 here? X-axis, where do we start at? -2, does it include it or no? Good, so -2 to 0, include or no? Yes, good. Then there's a break in the action, right? So we put a U, that means, whoop, we got a break. Then where do we pick up again on the x-axis? 1 to infinity. Awesome. So now we're going to read range. Range is low to high, bottom to top. Where does the graph begin? At -4. It includes it. And it goes, there's values, 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 and then still values, 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 values. It goes all the way up to what? Infinity. Perfect. Increase, decrease, constant. Where do we read increase, decrease, constant? On the x-axis. So let's go ahead and cross off the y. Don't make a silly mistake, guys. I don't care how high and low this goes for increase, decrease, constant. I want to know over the interval for which it happens. So increase, decrease, and constant. When I start on the left-hand side, on that open dot, and I follow the line, it's going in which direction? Decreasing. It's decreasing from where to where on the x-axis? -2 to 0. Perfect. Then I pick up my pencil and I put my finger on the next piece of the line. What is the graph doing? It's increasing from where to where? 1 to infinity. Is there an interval of constant? None. Put none, NA, no, whatever. All right, domain for this one. Ooh, -infinity to positive infinity. Wonderful. It's going to continually get wider and wider and wider and wider. It's a parabola. It's a quadratic. What is your range? Where does this graph begin to use values on the y-axis? 1 included to infinity. Perfect. Increase, decrease, and constant. Starting on the left-hand side, if you put your finger where that arrow is and follow the line, what's happening? Decreasing from where on the x-axis to where on the x-axis? -infinity to x-axis to 0. That's why I tell you guys cross it off. I know that's the hardest part on increase, decrease, constant. I don't care how high or low it goes. I want to know over the interval for which it's happening. So what happens then from 0 to infinity? It's increasing from 0 to infinity. Is there an interval of constant? No. No, that's just the turning point. All right, let's look at the next piece. What's going on? What do we have? Intervals of what? Oh, yeah, we'll talk about that in a second, but just look at your intervals. Increase, decrease, constant. What do we have? Decreasing and increasing. Is there a place where it just stays flat? No. Okay, good. So what's your domain, left to right? What's the furthest left we have values used? What's the furthest right? Tell me. -5, not included. 2. -3, included. Great. Union. Where does it start again? -1 to 1. Good. Then 3 to positive. Positive. We're reading left to right. I know the arrow's going down. Don't look at the direction of the arrow. You just know it's never ending. So it's going to continually, it's going to, yes, go down, but it's going to continually get wider. So now we're going to talk about our range. From the bottom to the top. Tell me, where do we start?
Infinity to 3.
Tell me again.
Infinity to 3.
What infinity is down here? Negative infinity. Right? Because this is still going down.
Wait, why are we starting?
Because range is from bottom to top, low to high. So it's negative infinity all the way up to? It's the highest that any piece of this graph goes. No, not positive infinity. What's the highest it goes? Just 3. Does it include 3 or no? No. All right, increase, decrease, constant. Increase, decrease, constant. Left to right. If I put my finger on that first little piece on the left-hand side, what is the graph doing? Decreasing. Only look at the x-axis. Over what intervals is this decreasing? -5 to -3. All right, then there's a break in the action. Then what happens? It's increasing from -1 to 1. Good. And then it's doing what? Decreasing again from 3 to... we're only looking at the x-axis, guys. Positive infinity. I understand the arrow is pointing downwards. I don't care what infinity it's going towards, up and down. I care that it's continually getting wider. We're only looking at the x-axis. Remember, a lot of times your increase, decrease constant will, if not be exactly the same as your domain, it'll mimic it in a way. Look at your domain versus your intervals of increase, decrease constant. Why are they similar or the same? Because you're on the x-axis. Can I just leave constant blank and just assume that you guys know that there is none? No, we need to say none or no, whatever. All right, you guys did great. I know that's hard. This is a very abstract thing to look at. It's so much easier to do those odd, even, neither when you're plugging in numbers and, it's very algebra based. This is difficult. This takes some practice, but you guys have to just keep repeating to yourself. Increase, decrease, constant. X-axis, parentheses only. Domain is left to right, range is bottom to top or low to high. Good job.